So you've heard of pH before, I'm sure. It tells us how acidic or basic a solution is. Typically in biology, they consider kind of the range of 6.5 to 8.2 is kind of a biological neutrality. In chemistry, it's a hard 7 because we're much more exacting in here. But typically for life to exist, you need to be in this range for the organism to be functional. Now, we do have stomach acid that comes in like up in this region with its pH, but your stomach has like a lining in it, a mucus lining that prevents that acid from eating away at your stomach. Yep.
Is there anything that could like degrade or take away that lining?
Yep. So if you drink too much alcohol, if you're under stress, there's a few other factors, certain medications, like they always tell you, like to take on, make sure you have food with this medication. Those sometimes degrade that lining. And then you can end up with something where the acid's eating away at your stomach, and that's called an ulcer. Okay. And sometimes people can have bleeding ulcers where those ulcers are actually bleeding. And then, they're throwing up blood and all kinds of yucky kind of stuff. So yes, that can happen. The other thing that can happen is you've had heartburn before. Yes. What heartburn is essentially you're getting some of that stomach acid up into your esophagus, and you can end up with ulcers in your esophagus. You can also end up with like people who are bulimic and they throw up a lot because of the bulimia. They can end up with their teeth getting eaten away from the acid. So it'll mess up their teeth over time as well. So you have probably tasted some of that mucus before if you've ever had the like dry heaves. If you've heard of that before, where you throw up to the point where you've got this kind of just mucusy kind of stuff that you're throwing up. You got nothing else, and you're just throwing that up. That's what that lining essentially is that mucus lining. And your stomach is continually like creating that, and it's protecting you from that acid getting to parts it shouldn't. So, all right. So pH, like I said, is a measure of how acidic or basic. It comes from the power of hydrogen ion. Because remember what we're doing with these acids and bases. With acids, we're donating hydrogen. The pH then in chemistry, so this is our range of pH in here. We consider acidic to be 0 to 6.9. Neutral is right on 7. And then basic is 7.1 to 14. Here is a kind of color chart that shows you what those different pHs and different things that are associated with them. So like cow's milk and your spit usually comes in around 6. Rainwater is usually around 5 to 6 in this kind of general range, but pure water is at 7. Seawater is a little basic. If you get into AP Chem, we'll talk about why that is. Baking soda, and you can keep going down until you get to like liquid drain cleaner. There are some liquid drain cleaners though that are actually acidic. So just depending on what you get determines what that is. But like soap water, you felt that slippery feel. That's a base. Yeah, right.
At what point do you consider? At what pHs do you consider like, okay, this could actually hurt me?
Typically, around the 9s and up, and probably the 4s and up, depending on, the concentration of it, and depending on what you're doing with it. So, for example, if I get if I have an open cut on my hand and I got a little bit of tomato juice in it, it would probably burn a little bit. Now, am I going to be permanently maimed from that? No. And honestly, it depends on how much of it if it's one little drop, then you're probably not going to do that much damage. You get a whole like big thing of it, and that could possibly do some damage. You get a little bit of that tomato juice in your eye, okay? You're going to feel it, okay? So I would say right around in there. I mean, typically most of this stuff in this range, is not going to really hurt you. All right, so you should have learned yesterday in your activity that you had pH equaling the negative log of your hydrogen concentration. Remember that these square brackets mean molarity. We talked about molarity. That's moles of solute. We did this in chapter 14 over liters of solution. Okay, that is what your molarity is. You're going to take the negative log of that, and that's going to give you the pH. The more H plus you have, the more acidic you're going to be, and the lower the pH. You can actually have, for really, really, really strong concentrated acids, you could actually have negative pHs. You can go into the negatives. All right, if you want to go back the other way and figure out the H plus concentration, you're going to take 10 to the negative pH, and that's going to give you the H plus concentration. So you can go back and forth between those. Okay, so the first thing that they're going to have us do is calculate the pH of a solution that has an H plus concentration of 1 times 10 to the negative 2. So on your calculators, you need to type the negative button, which is not the same as the minus. You're going to type the log button, and then you're going to do 1. And for most of you, you're going to do second and activate that EE button. And then you're going to type in a negative and 2 and equals. And you should come up with 2 as your answer. If you didn't get 2, well, number 2, positive 2, then let me know so I can come around and help you with your calculator. Everybody okay with that one? You got what? Good. Okay. All right. The next one then is going the opposite direction. So this one, you're going to calculate the H plus concentration. So you're going to type in, for most of you, it's going to be second. And then you're going to type in the log button, which will actually give you 10 to the X. By hitting the second, you're going to get this 10 to the X. And then you're going to type in the negative 2.4 and then hit equals. And you should come up with, yes, indeed it is 5.4. Okay, let's try that. I typed that into my calculator right at least. So I ended up with 3.98 times 10 to the negative 6. This is how you write this down. You don't write down 3.98 E minus 6. Okay, don't do that. You need to know how to format it properly. Make sure that when you're doing one of these problems that you always look all the way in your display screen. Make sure that you look all the way over to the side here to get that negative value. It should say, so it's 3.98 and then a whole bunch of other numbers here. And then this. Merritt.
Can I see the equation for 3?
For what?
Up at the question 3C, like the equation for calculating H plus.
This?
Yeah, the other one.
This?
Yeah.
Okay.
I'm confused on what you did for the.
For which one, hon? You good, Merritt?
Yep.
For this? For which one?
The one we just did.
Okay, so you're going to hit the second key on your calculator, which is up at the upper corner, the blue key on your calculator. You're going to hit the log key. And on your calculator at that point, it should say 10, and your cursor should be sitting right here.
Negative 5.4?
Yeah?
Okay, there we go, yeah.
Okay. All right, everybody else good with their... All right. So this log scale, the reason why I was able to do this one so quickly, I didn't need to do it in my calculator, was because if it's 1 times 10 to the negative 2, that's going to give us a pH of 2. 1 times 10 to the negative 3 is going to give us a pH of 3. And you can see that these are 10, a unit of 10 difference between these. Okay, this is 10 times more than this guy. Right? Now that works without using a calculator if the number in the beginning is 1. If it's not 1, then I got to use a calculator. All right. And this is what that looks like in terms of here's my pH, here's what that number looks like. All right. On the flip side of pH, we have pOH, which is the power of the hydroxide ion. Done the same way. So if you have the pOH, that's going to give you the negative log of the OH. The more OH you have, the more basic it is, the higher the pH is going to be. Good. Got the equation written down? Everybody's good? Okay, moving on then. And just like you did with the pH, you can get the OH by doing 10 to the negative pOH. All right, everybody good? All right, so I want you to spend a second. You should be able to do both of these problems, and I'm going to put the answer up here on the side, but I want to make sure that you can do these on your own. All right. Good?
No.
Okay.
I got lost.
Which one? The first one?
I forgot where. Well, I don't know where to start.
So for this one, remember that pOH is going to equal the negative log of your OH concentration. So I'm going to, on my calculator, I'm going to type in the negative key. I'm going to hit the log key. I'm going to type in 8.2. I'm going to hit the second key. I'm going to hit the comma key, which has the EE key up here. And then I'm going to type in the negative and 6 and hit equals. Did you get it to come up?
I'm going to try to write this down.
Oh. For down here, you are going to hit the second key. You're going to hit the log key. That will then activate the 10 to the x function. Then you type in 2.5. Then you're going to hit the second key again. You're going to activate the comma. Nope, I don't need to do that. I need to back up. Hold on. I needed to type in a negative here. And then just equals. There we go. And then that should give you that number.
Wait, isn't it 9.6?
Yes, it is. I'm sorry.
I'm fine. I'm going out of it today too.
I grabbed that number right there. Sorry.
Fine.
And then that should equal this value up here. All right, you good? Were you able to get those? Anybody need me to come over and help them with their calculator? All right. So acidic solutions are considered to have a hydronium concentration of 1 times 10 to the 7th or greater. And basic have an OH concentration of 1 times 10 to the negative 7th or greater. Now this is at 298 degrees Celsius. And here we're just going to assume that all of our reactions are at that temperature. So this is going to be a given for you in here. Okay. All right. Pure water at 298, which is what we're going to assume that we're at, is going to have a pH of 7, which means that our hydrogen concentration and our hydroxide concentration are going to equal each of these. And if we multiply those two together, they're going to equal 1 times 10 to the negative 14. All right, so if you know pH, then all you have to do is subtract from 14 to get pOH. And again, this is at 298. Everything in here, we're going to assume at 298, so this will all hold true. Temperature will change this, but you don't have to worry about that this year. Next year, we talk about it some in AP, but it's not a terribly sticky topic at that point because you've had enough experience with it that you should be comfortable. Okay. All right. So if we are given OH here or given H plus, then you're going to try to state whether the solution is acidic, basic, or neutral. Okay. So they want us to calculate here. They want us to calculate our OH concentration. And then we're going to say if it's acidic, basic, or neutral. Here they want us to calculate the H plus concentration and then say if it's acidic, basic, or neutral. Okay. So this is my H plus concentration. What would my OH concentration be here?
1 times 10 to the negative
1
power.
Yep. Okay. If my H plus concentration is this, what is my pH?
Let's go back.
It's a 1. It should be easy. What's my pH? 13. Yep. So is that acidic, basic, or neutral? Basic, yep. All right. So here, this is 1 times 10 to the negative 9. My H plus concentration is going to be 1 times 10 to the negative 5. Okay. So if this is my H plus, what is my pH? 5. Acidic, basic, or neutral? Acidic. All right. That's it. You got some practice problems tonight. It's like it's a little over a half sheet, but not too bad. I'm going to hand out your quiz. Then you can work on getting that homework assignment done for tonight. Hopefully all of that stuff you can get done before you even leave here today. And then if you want to go back and do any kind of corrections to quiz 1, that is available for you as well. So you should have a calculator. I don't even think you need a calculator for this quiz, to be honest with you. You can have it if you so choose, but I don't think you really need it. Just taking over your desk.